We're having a look at computer vision, classification into different chest conditions. I won't go into the medics of it as I'm not that sure of it, but basically we've got our 4 divisions here, and when we come in here we can see we've got our testing and training data in zip file, and we can see how Data Robot will handle this. So we'll go creator of a project, local file, get the lung disease training data. You can see it's actually handling that. It's uploading the data and it's going to be reading everything and working through. I'm going to pause here while that all loads up. So that's all been loaded, and now we need to select our target, and basically we'll type in here class. It knows that's the one there. We can see we've got our 4 number of records, everything showing here, same modeling data sets. What we can now do is we've got different models here. We've got quick, autopilot, manual, comprehensive. We can set all the different things. At the bottom here we have show advanced features, so we can partition our data, extended partitions, bias and fairnesses, etc. One thing I forgot to say in the first video is in the AI catalog we can pull in data sets from all different places, and it can be merged and cleaned and all different things like that. So actually inputting data into Data Robot can come from many different sources to create a catalog which we then use in our models, etc. So if we go back to data and we'll click start, it's going to take a little while. So basically categorical, let's just check that we've got this, is it's all running through. I'll leave it for now, but it's going to be going through. If we know the model that works best, or the best algorithm, or the best maths, we don't have to sort of run this data set through all the different types of models. We can just have one particular model, but this is when we don't know, we can find it. Also, we might look at features. We can identify cross-pairing of features, which are the most important. So I'll pause here for a while until all of this is done.
As a Keras model. We also, if you go up, you should be able to see there is another Keras limb residual neural network as well. And if you simply click on it,
I picked under this one here, we can see under evaluate, if we go into evaluate, we can see different factors here, confusion matrix, ROC curve. Understand will show us initializing data, enable feature impact report. It's being queued at the moment. Predictions, evaluations, as we've sort of seen, lift charts, all of that stuff is here. So we're just going to pause a little bit so we'll get through all the processing. While it's going through, we can actually see in the describe, we can actually see the process it's going through on the CNN. It's not doing image augmentation, but it's using one of its highly trained models. And there is the Kaggle data science machine learning competitions at kaggle.com. And basically, I think this one won its competition. So all these models that are being used by Data Robot kind of compete in competitions. So they're very high performance. And you can see how we get our prediction at the end here. The neural network visualizer, where we can see what's actually happening between activation layers, etc. So everything one can think about or maybe want will actually be in Data Robot. If you've thought about it, somebody else has, and they've developed a solution for it. We can also see an example of the confusion matrix as well that we can get under the evaluate, under all these different things. And we also have advanced tuning if we want to do things like that, batch size, etc. Well, it's already found one of its leader, which is a Keras Slim. We've got the accuracy 0.898, validation 0.924. If we prepare it for deployment into predictions, create deployment, deploy model. That's all the stuff there. Create deployment here. There we go there. That's kind of ready, nicely deployed. So what we'll do now is we do some testing. So we go to the file, local file, and what we're going to do is pick up the testing data. It's loading it all in. I'll just let things run through, but you can see it's adding in all the data there. We can see we've got 12 rows, and that was in our data set here. So we'll compute predictions. That's going to do its work. It's queued, so I'll come back. And what we can do is we can download the predictions. It's going to be in a CSV file. I've downloaded it here. If we open that up, and it follows the naming conventions with the predictions, lung disease. It's predicting pneumonia. We can sort of see here that it's coming across 0.88. If we look at the file name, this is bacterial testing, and actually it's predictions healthy. COVID testing, that's coming up high, 0.98, 0.98 here. Healthy testing, prediction healthy, 0.41, 0.58. Hasn't predicted that one, but as you can see, that's actually how we also do the actual sort of testing. Bacterial testing, there it's 0.871, prediction healthy. So that's picked it up correctly. That's 0.87. So bacterial testing, COVID testing, it's predicting COVID 0.99, 0.99, and that's it. So that's really how we can use computer vision to scan these images.